Alright, welcome to 9.3 Equations of Quadratic Form. So, this video, we can see right off the bat, is about our quadratic stuff, right? we can see factoring is our first method. Then we learned about square root property, completing the square and quadratic formula in this chapter. So we took an entire chapter on factoring, obviously the most powerful, but definitely not the only way to solve a quadratic. What this section is about taking stuff that doesn't look quadratic and solving it as if it was. Okay, so we're going to solve this quadratic, or this rational equation, as if it was quadratic. We're going to first convert it to a quadratic, and then we'll use some of our quadratic stuff to solve for it. Excuse me. Alright, let us recall that this is a rational equation. Right? Rational means it has some fractions in it, and one of the variables is in the denominator, right? This one actually has 3 fractions in it with 2 variables, or 2 different it has x in 2 different terms of the denominator. And in order to solve these guys, we're going to need a common denominator. So let's start with that LCD. That LCD, remember, you just take one of each of those guys. Luckily, they don't have anything in common. So our LCD is going to be x, x minus 1, and 12. One of each, right? And then the goal here is to take that LCD, we're going to multiply it by all 3 terms so that eventually all these denominators go away. That's the plan. We want the denominators to go away and get something nice and quadratic looking that we can solve with probably quadratic formula or factoring or complete the square. So let's take these one term at a time. Excuse me. I have 1 over x. And now I'm going to multiply by what's missing from my LCD. Well, I have the x part. I just need the 12 and the x minus 1. And I'm going to multiply that to both the top and the bottom so I don't change anything, right? Technically, I'm multiplying by 1 here. Multiplying by 1. I'll do that to my next term. My next term was plus 1 over x minus 1. What's missing from this one? I have the x minus 1 part. I need the x and the 12 part. So I'll do 12 times x over 12 times x. And then in my last part, that equals 7 12s. I want to do the same thing. I want that to have the same denominator. So what part's missing? It's got the 12 part. Just needs the x minus 1 and the x. So x minus 1 over x minus 1. Those are my 2 things that I need to multiply. That's how I'd multiply by 1. Okay. So let's actually hammer this out now. Start over here. Up at the top, I have multiplying by 1 doesn't really do much. Multiplying 12 in there, we end up getting 12x minus 12 over that denominator of x minus 1 and 12. I'm not multiplying those guys out because I don't need to. I don't need to. If I do, it doesn't really matter because they're just going to match in the end anyways. So I'm saving myself some time. But the numerator, I need to know what sits up there, right? So I can combine like terms later. Second term, again, multiplying by 1 doesn't really do anything, so I'm just left with a plus 12x over x minus 1, and 12. Alrighty. Last one, let's multiply this guy. This might take a little bit more time. If I multiply that in, I end up getting 7x times x minus 1, right? And then I multiply those guys in, I get 7, okay. So then down here I can get 7x squared minus 7x over the x minus 1, and 12. And so that's how I get that. Next, I'm going to combine this left side into one fraction. I don't like the fact that I have 2 fractions here. So I'm going to put them, since now they're the same denominator though, I can put them over the same denominator. So that denominator here is x minus 1. Actually, I don't want to write it. I need some more room on the other side, sorry. It's going to be x minus 1, and 12. The numerators are now 12x minus 12 plus 12x. And then I just have the same thing on the other side. The exact same thing as before. X minus 1 and 12. So I just combine these 2 into one fraction. Sweet. Since they have, in order to get rid of this denominator over here, I can multiply that by on the top. So I'll multiply by x minus 1 and 12. So that the x's cancel, x minus 1 cancel, and the 12 cancels. Do the same thing over here, x minus 1, and 12. And luckily, they do cancel, right? That's the whole point. That's the whole reason I wanted these to match. So when I multiplied over here, it would match over here, and it would also cancel. Oops. It would also cancel. And I'm just left with the numerators. That's what I wanted to happen. So I can take my numerators over here. 12x minus 12 plus 12x equals 7x squared minus 7x, right? That's what was sitting in my numerators. And now I've got stuff that is on the verge of being quadratic. So the whole point of finding that LCD was to make it all match and get rid of the denominator so that everything was just a nice whole number. Alright, I can combine some terms here. I've got 24x minus 12 is equal to 7x squared minus 7x. I can move these guys over here. 0 is left on this side. 7x squared, 24, so take away 24 from negative 7, you get negative 31 plus 12. Okay, and we've got a quadratic. So we took something that was not quadratic and we made it quadratic. Now we can use any one of these guys to solve it. I know 9 out of 10 of you are going to want to use the quadratic formula. Fine, go for it. I'm going to do factoring because it's just going to be 10 times easier. So when I factor this, let's see, two things. Let's see, what's 7 times 12? I believe 84. Two things that multiply to 84 and add to negative 31. Think 28 and 3. Let me try 28 and 3. Okay, let me try 28 and 3. 28 and 3 does multiply to 84, and it does, well, it doesn't add to it doesn't add to negative 31 though, so maybe negative 3 and negative 28? Okay, sure. So I'll do negative 3. So minus 3x minus 28x plus 12. Factor by grouping. 0 equals, okay, the only thing here is an x, so 7x minus 3. Over here I've got a minus 4 in common, so I'll take out leftover 7x minus 3. And getting x minus 4 times 7x minus 3. I'm going to put the 0 on this side because I feel like it. So either x is equal to 4, or 7x minus 3 is equal to 0. So we'll say 7x is equal to 3, x is equal to 3/7. And I have arrived at my two solutions. But this is irrational, so I got to double check that both of them in fact work. Let's take a peek. 1/4, 4 minus 1, neither one of those is going to give me a 0, that's good. 3/7, 3/7 on the bottom, that's okay. 3/7 minus 1, so it's going to be a negative number, it's not going to be 0, so yep, no extraneous solutions, we are good. Alright. Yes, it's a bit of work, as we remember from rationals, but the only additional work here is the solving of the quadratic. So really it's just putting together two ideas that we've done already, right? Two ideas that we've done already. Rationals, make them quadratic, find the solution. Let's do another one. So here I have 1 plus 2 over k equals 3 over k squared. So my LCD here, we can put up here, it's going to be, and when I take one of each, I want to be careful. I want to be careful because this is k times k, right? So really my LCD is 1 times k times k. This one already has a k, right? It already has a k. So, sorry. When I write down my LCD, I want to write down 2 k's at most. I'm treating it in my factored form, right? So factored form. Alrighty, and this is 1 over 1. So let's take our first term, 1 over 1 times, let's see, what's it missing? K over k, or k times k, over k times k. It's missing the 2 k's. My second term is plus 2 over k, right? And what's it missing? Just a 1 and a k, so I'll just multiply by a k. And then the last one, my last term is 3k squared. So I'll multiply by, let's see, it's actually not missing anything. It has a 1, a k, and a k squared, so I don't need to multiply by anything over there. Alrighty. Simplify this guy, we get k squared over k squared. The red one ends up giving me 2k over k squared. And then as we already discussed, this last one doesn't change. And now everything has a k squared below it. Sweet, everything has a k squared. Combine these two guys, I get k squared plus 2k over k squared is equal to 3 over k squared. Now when I multiply to k squared to both sides, I can see all these k squares start to cancel, and I can see that k squared plus 2k is equal to 3. Awesome, so I took away the denominators by putting them in the numerator, right? I took away the denominators by putting them in the numerator. Then I can move the 3 over to one side. I get k squared plus 2k minus 3 is equal to 0. Okie dokie. And I end up getting, let's see, so I can factor that as well. Two things that multiply to negative 3 and add to 2. Positive 3 and 1. So I get k minus 1 and k plus 3 is equal to 0. So k is equal to 1 or k is equal to 3. Alright, k is equal to 1 and k equal to 3. Let's check that none of those cause a problem. 2 over 1, that's fine. 3 over 1 squared, that's fine. 1 plus 2 does equal 3. 3 2/3, that's fine. That's not a problem. 3 over 3 squared, that's fine. That's not a problem. So both of these are good. No extraneous solutions. Check. There is an alternate form to this when it comes to the LCD. If you wanted to, you could say that your LCD was k and k squared, literally taking one of each. You would have ended up with an extraneous solution of k equals 0, though. That's the only thing that would have happened, and you wouldn't count that as your answer because it would be an extraneous solution, right? You can't have 2 divided by 0. If you went that route, just make sure you watch out for extraneous solutions. I always like to go by the literal least common denominator, but if you up until this point have just been grabbing one of each every single time, it's fine. If you are one of the people who did that and don't really know what I'm talking about, come see me in person and we'll do it together, okay? Alright, so that's solving irrationals. It's solving rational equations with quadratic ideas. Let's see about radical equations with quadratic ideas. Excuse me. Okay, so if you recall, this is a radical equation. I've got a radical on one side, right? Lucky for us, the radical in this one is entirely taking up the side, right? So it's taking up one entire side, so I can use power of equality. You know what? I'm going to rewrite it. X equals that. Take a square of both sides, power of property of equality. So x squared is equal to 6x minus 8. Awesome. Now remember, when you're using the square root property that we talked about in this chapter, you need to throw on the plus or minus. But everything squared is going to be positive, so hence that whole complex discussion. But everything that's going to be squared is positive, so I don't need to put plus or minus x squared, right? That's only if I take the square root, only if I go down. Okay. Now this looks very quadratic. I can just move these guys over. Again, I like to move things towards the squared term. If you want to make it easier and move the other one, move the x the other way, that's fine. You'll just have a negative x squared, and then you'll have to deal with that, but that's okay. So I get x squared minus 6x plus 8 equals 0. I could solve this by factoring, but I feel like I've done that 2 times now, so I'm going to solve it by quadratic formula. Just to remind, actually, I'm going to solve this by complete the square. So I have x squared minus 6x plus 8 equals 0. Complete the square means I want to take the c, get it out of the way. I end up with x squared minus 6x equals negative 8. Okay. Now I need half of this, so negative 3 squared is positive 9. So I'll put positive 9 on both sides. I end up getting, let's see, that factors down to x minus 3 squared is equal to 1. Sweet. Now I take the square root of both sides. I get x minus 3 is equal to plus or minus the square root of 1. And again, I'm not simplifying until I hit the end, right? Then I move the 3 over, I get x is equal to 3 plus or minus the square root of 1. Square root of 1 is equal to 1, so I get 3 plus or minus 1. In other words, I get x is equal to 3 plus 1, or 4. Or x is equal to 3 minus 1, or 2. And there is my solution. X is equal to 4, comma 2. Should have arrived at the same thing had you done quadratic formula, or if you'd factored. We can see that two things that multiply to 8 and add to negative 6 would be negative 4 and negative 2. Then you solve by zero product property, you get 4 and 2 as well. Okay, let's try another one with a radical in it. Let's use orange. I have x plus the square root of x equals 6. Now before, when we had, I always kind of mentioned to take the radical at the end, take a square at the end, right, if you have a radical on one side. I still recommend that. So I'm going to move this x over here. I get x, or root x, is equal to negative x plus 6. Or 6 minus x, same thing. Remember, you actually can't, it's against the rules to take a square on this side and square them individually. It's not possible, right? That's when God kills kittens. That's when things fall apart, right? So you can't do that. You got to move the x over first, then take the square of both sides. Oops. We end up with just x on this side. And then I have a negative 6x times itself. Again, I can't distribute. That's when God kills kittens. So I'm going to do negative x plus 6 times negative x plus 6 times itself. I end up getting a positive x squared, a negative 6x, a negative 6x, and a positive 36. So that would be x squared minus 12x plus 36 is what I get on this side. X squared minus 12x plus 36. Okay, this would be awesome. It looks very quadratic, except we still have this x over here, so let's take care of that. I get 0 is equal to x squared minus, so if I take away 1, that's going to be negative 13 plus 36. Again, I can solve this using factoring. I can solve it using complete the square, but for you quadratic formula lovers out there, I will use quadratic formula. X is equal to minus b plus or minus square root of b squared minus 4ac, all over 2a, right? So you got to memorize quadratic formula if you're going to use quadratic formula. That gives me a positive 13 plus or minus the square root of 169 is negative 13 squared. 36 times 4, it's 144, minus 144 over 2. 169 minus 144 is 25. So 13 plus or minus square root of 25 over 2. Luckily square root of 25 is a perfect square. So since I'm looking here, my discriminant tells me I should get two numbers, right? My discriminant tells me I should get two rational numbers, two real rational solutions. So I have 13 plus or minus 5 over 2 now. And then from here I got to go two rows. 13 plus 5 over 2. That's going to be 18 over 2, or 9. 13 minus 5 over 2. That's going to be, let's see, 8 over 2, which is 4. So I end up with x is equal to 4 or 9. Should have found the same thing via complete the square or factoring. You would have gotten the same exact answers. Alrighty, so that's using quadratic ideas to solve radicals, okay? So you use your radical ideas and then you use your quadratic ideas. And I showed you can do factoring, complete the square, or quadratic formula. You end up getting the same answers. Now let's try some word problems. So we've got some word problems that can be used, we can use quadratic equations to solve. First one, a riverboat of Fortress averages 12 miles in still water. If it takes the boat An hour and 4 minutes to go 6 miles upstream and return. Find the speed of the current. This sounds very, very familiar to our rational word problems, right? So let's go ahead and solve this guy. Remember, we're going to use the formula distance equals rate times time. Purple. Distance equals rate times time. And then we're going to set up sort of a little table for when those two things are happening. Oops. Slow down. Alright, so we've got upstream and downstream. We've got distance, rate, and time. Okay. Well, if you're going on a round trip, you better be going the same distance. So we may not know this distance. Wait, do we? Yes, we do. To go 6 miles upstream and return. They go 6 miles upstream and return 6 miles downstream, right? It says that in still water, they average about 12 miles per hour. So that's the rate of the boat, right? When they're going upstream, that 12 miles an hour is being hindered by the fact that they've got the current coming at them, right? They've got the current coming at them. So whatever that current is, we can call it R, rate, it's going to be taking away that 12. Oops, I did it backwards, my apologies. Sorry. That 12 miles an hour is going to be taken, that rate is going to be taken away from their 12 miles an hour. If their current was 8 miles an hour, and they're going, if the current was 8 miles an hour, they're going 12 against that, they're going to average out about 4, right? So whatever it is, it's 12 minus the current of water. And then the same opposite applies when going downstream. You're going to have 12 plus whatever the rate of the current is, right? If it's 12 miles, they're already going 12 miles, and then they get 8 mile an hour push, they're going to be going 20 miles per hour, right? It's going to be awesome. Everybody's been downstream. It's much more fun than going upstream. Or downhill versus uphill, right? All right. So far, so good. The last part, they did give us a time. That's a total time. We don't know the time upstream or time downstream, right? It's not going to be constant like the distances. It's going to be a little bit of each. So we can use this formula where d over r is equal to t, right? When we solve that for t. And we can plug it into each going upstream and downstream. So 6 would be distance over rate. Let's make these x's so we don't get confused with rate. So distance over rate. So these are x's now. 12 minus x. And then the same thing for going downstream, 6 over distance of 6 over 12 plus x, which would be their rate going downstream, right? Okay, their total time is 1 hour and 4 minutes. That is completely unusable as they've written it. So let's take just a millisecond over here to convert that into something we can actually use. 1 hour, 4 minutes. Let's put this into a fraction of hours. Okay, so fraction of hours. So I have 1 hour, 1 over 1, plus 4 minutes, right? 4 minutes. Let's do this in 60 minutes since we have minutes here. So 60 minutes over 60 minutes plus 4 over 60 minutes, right? I'm basically just adding these into minutes, so that's 64 out of 60 minutes. 64 out of 60 minutes. I wonder if we can reduce that because I don't like the 60s going here, but I see a 2 that I could reduce by. 64 divided by 2 would be 32 over 30. Even better, I can do it by 2 again. I get 16 over 15. And those are no longer even. Okay, so they were actually going for about 16 over 15 minutes. Hours. 16 over 15 hours. Okay, so now what we know is that's our total time, right? Our total time will be 16 over 15. That's going to be equal to the time upstream, which was that expression, plus the time downstream, which was that expression, right? And we have our equation. We have translated. Let's go ahead and solve. Let's solve using our quadratic ideas. So we have an LCD of 12 minus x, 12 plus x, and 15 here. LCD is 12 minus x, 12 plus x, and 15, right? So let's multiply each one of these terms by that, by what's missing. So 6 over 12 minus x times, let's see, that one has the 12 minus x, but the other needs the 12 plus x and the 15. So 12 plus x and the 15, right? The next term, very similar, but this is the 6 plus 12x. So it already has the plus version. It needs the 15 and the 12 minus x version. Multiply by both of those. And then the last one, let's see, 16 over 15 needs both versions of 12 plus x, 12 minus x to both, right? Plus x, 12 minus x. Alrighty, so now we can simplify this down a little bit. I'm going to put these over one common denominator, just from the get-go. Excuse me, of 12 minus x, 12 plus x, and 15. Up on the top here, we'll multiply these out. I get 6 times 15 is 90. Yep. Times that by the 12, you get 1080. Times that by the minus x, you get minus 90x. So that's what I get when I simplify the top here. Over here, I still have 6 times 15 again, so that's another 90 times 12, so plus 1080. And then again, minus 90. Oops, sorry, that was a plus x, so that should be a plus. Over on the right-hand side, I have a denominator of x. Oh, no, I don't. 12 minus x, 12 plus x, and 15, right? And then up here, see, 12 times 12 is going to be 144. So this is going to be 144. 12 times that's going to be minus 12x plus 12x minus x squared. Sorry, I kind of ran out of room there. That's all still being multiplied by 16, so I end up with 144 times 16 would be 2304. My x's cancel each other, and I get minus 16x squared. So there's a lot going on here. Just make sure you break it down piece by piece, little in multiplication by multiplication. We can simplify a little bit. First off, two denominators, they cancel each other out. Up here, those guys cancel each other out. I'm left with 1080 plus 1080 is 2160. Is equal to 2304 minus 16t squared. Oh, good. Not t. I don't know where I got t. Sorry, x. X squared. Luckily, now we only have one x term, so we don't even need to use factoring. We don't need to use complete the square. We don't need to use quadratic formula. We can just use square root property because this only has a square in it, right? There are no more x terms. That makes life easier. So we'll start as far away from the variable as can. So, oops, I'm so sorry. I didn't mean to divide that because I meant to subtract it. Subtract 2304. Subtract 2304 is negative 144. I'm going to sneak up here now. Negative 144 is equal to negative 16x squared. Ooh, this just got so much prettier. Look at how nice. Divide by negative 16. You get 9. Positive 9 is equal to x squared. Now we do square root property. Plus or minus 3 is equal to x, right? Square root, square root. And so our solution is plus or minus 3. However, now we need to translate back which one's the only one that makes sense as a speed or a current. That would be the positive version. So this would be 3 miles per hour is our final answer. Alrighty, this problem should have been super new. The only new part would be getting down to here, right? Once you got here, once you whittled it down to a quadratic, we can use the square root property and figure out that it's 3 miles an hour. Alrighty. Let's try another one. It takes 2 carpet layers 4 hours to carpet a room. If each work alone, one of them could do the job, in 1 hour less time than the other. How long would it take for each carpet layer to complete the job alone? Alright, so it sounds a little different from the other work problems we've done so far this year, because they tell us in terms of each other, right? In terms of each other. So let's call the first guy, I don't know, Carlos and Dan. Carlos and Dan. Or Carla and Dan. It could be a girl, right? So Carla and Dan. Let's say Carla does it in X amount of hours, and Dan can lay the carpet in 1 less amount of hours, right? So if Carla does X hours, then Dan is X minus 1 hours, right? Okay, cool. Remember, if you can do a job in a certain amount of hours, then that's the same thing as your work rate 1 over however many hours you do, right? So if Carla could do it in 3 hours, her work rate would be 1/3. If Dan can do it in 8 hours, his work rate would be 1 over 8, right? So in this case, that means that Carla's work rate is 1 over X, and Dan's work rate is 1 over X minus 1, right? So that's the work rate. Together, they both do 4 hours. You can put this in a table. I'm just kind of writing it out, though. Together is 4 hours. And so the fractional part that Carla does, whatever of that 4 hours, is going to be 1 over X times those 4 hours, right? So that part is going to be Carla's. And then Dan's is going to be 1 over X, his work rate per hour, times the 4 hours, right? So Carla's going to be her work rate times those 4 hours. Dan's going to be his work rate times those 4 hours. That's how much they're going to get done individually. And then together, 1 over X times 4, there's Carla, and Dan working together will get the 1 whole job done. Together we'll get the 1 whole job done. And we have translated, okay? So convert to your work rate, multiply it by the time they can do it together, and then put those fractional pieces together, right? So you're looking for each fractional piece of a person, because that's the question, right? How long will it take each of them to complete the job alone? And so when you put them together, you have to have those fractions together. Alright, let's solve this bad boy. So I have 4 over X minus, plus 4 over X minus 1. All I've done is put the 4 on the top now. Is equal to 1. LCD of X minus 1, and 4. Very similar to the first problem we did in this section, right? Let's go ahead and use that LCD to make all the denominators go away. 4 over X. What's missing from that one would be the X minus 1 and the 4. Why did I write 4? Sorry. There's no 4 there. 4 is in the numerator, Miss K, you silly. So it's just times 1, so I can just do it times 1, or I could just leave it off. I think I'm just going to leave it off. 4 over X, the part that's missing is the X minus 1 and the X minus 1. Plus, let's try Dan. What's Dan missing? Dan is 4 over X minus 1. What's missing from there is an X over X. And then the total is missing both. I have 1 over 1, because it's the same thing as 1, right? Times the X minus 1, over the X minus 1. Alrighty, let's simplify this a little bit. The 2 things on this left-hand side here are going to become 1 denominator. One big, I won't go 2 steps at a time. So let's just simplify the first guy. We get 4x minus 4 over x times x minus 1 plus, see that was Carla, Dan would be 4x over x minus 1. And then on the other side, let's see, we have x, well all this is times 1, those both go away. X times x would be x squared minus x times negative 1 would be negative x over x minus 1. Alright, I got all 3 denominators the same. So I can make this one into 1 denominator. X minus 1. On top here I have 4x minus 4 plus 4x. So 4x minus x, nope, minus 4 plus 4x, right? So I put all the numerator together, and that is equal to, well, I'm not going to really change anything yet on this side, so I just have x squared minus x over x minus 1. Awesome, the denominators match now, so I can multiply on this side by that denominator, and it goes away, and I'm just left with 4x minus 4 plus 4x on this side. When I multiply one side, I have to multiply the other, regardless of what it is. And luckily, because they match, they both go away too, and I get x squared minus x. And all the denominators are gone. Fabulous. I hate denominators. I don't want to deal with denominators. Let's keep going. Got some like terms on this side. I get up to 8x minus 4 equals x squared minus x. Move those both over here. Get 0 equals x squared. Let's see. Take away 8x from x. You negative 9x plus 4. All right. Looking good. Looking good. Alrighty, I don't think this one's going to work with factoring, unfortunately. Nothing I can see is going to multiply to 4 and add to negative 9. So let's use quadratic formula. I know you guys partial that one. Complete the square would also work, but let's use quadratic formula. Okay. So x is equal to minus b is going to be a minus negative 9. I don't have room over here. Kidding, I thought I did. Let's go delete, let's erase this, and we will work right here. Okay. So x is equal to minus negative 9 plus or minus the square root of b squared. So negative 9 squared plus b squared minus 4a is 1. 4 times the silly blue thing. 1 times, let's see, 4. All over 2 times a. All over 2 times 1. Okay. Negative 9 ends up giving me a 9 plus or minus. 81 is 9 squared. Minus 16 would be 65 over 2. 65 is not a perfect square, but I can try reducing it. So let's try. I don't think it's going to reduce much though. Actually, I take that back. Let's not try reducing it. Let's just convert it to a decimal so we can actually get more of a decimal answer. So the square root of 65 is about 8.6-ish. 8.06, pardon me, 8.06. So 9 plus or minus 8.06 over 2. And so we get two answers. You get 9 plus 8.06 over 2 is equal to about 8.53. And 9 minus 8.06 over 2 is about 0.53. Alright, so we solved. Those are our two solutions. The question is what's the final answer? What's the final answer? We have to make sure that both of these satisfy the problem, right? So let's take a look. This is rational. We have to make sure it satisfies the equation. Putting a 0.5 on the bottom. Well, let's start with the 8. 4 over 8.53, okay, that's a horrible looking decimal in a fraction, but it's still going to be positive. 8.53 minus 1, yeah, that's still going to be a positive. That one's okay. So that would not be an extraneous solution. 0.5 as a denominator, again, not great to keep it that way, but it's okay to start. It is still a denominator. 0.5 minus 1 is a negative 0.5. Now that's not a problem as, a number. But can a work rate be negative? Can Dan's work rate be negative? That doesn't make any sense. So this could not be his answer. right? Our answer would have to be 8.53, which means 8.53 hours. That work rate was for Carla. If x equals 8.53, then that's Carla. And then Dan is 1 hour less than that, or 7.53 hours. That's how much they take to do alone. All right, sounds good. We have our solutions. All right. So that's the first part of this section, or that's the second part of this section. We've solved a couple things with quadratic now. Let's keep going. Let's solve some other things that kind of look quadratic. The last thing we're going to talk about today is solving using U substitution. So we've talked about this once before and how it, can be helpful. Take things that look horrible and then make them prettier. That's the idea. So we're going to take this U idea. We're going to take out things that are not nice, like x to the fourth, and we're going to replace it with U. Okay, so I've got this equation. X to the fourth minus 13x squared plus 36 equals 0. This is a quadratic equation. This is not a quadratic equation as it is, so we need to change it so that it is a quadratic equation. But what I'm noticing here is it looks very quadratic, right? It looks like almost the right setup except for the powers. So I'm going to try and change the powers. I'm going to let U equal x squared, kind of like they recommend here. Let U equal x squared. So for every x squared, I'm going to put in a U. First thing I got to remember is that x to the fourth is an x squared squared. So this first guy becomes U squared. Minus 13, there's another x squared, so that's going to become a U. Plus 36 equals 0. Now it's a quadratic, and now I can solve. So notice how that works. I substituted out something horrible so I could put something nicer in. I'm going to solve by factoring. Two things that multiply to 36 and add to negative 13 would be negative 4 and negative 9. So I get U squared, it's okay. I get U minus 4 and U minus 9 equals 0. And therefore U is equal to 4, or U is equal to 9. That was factoring. I used a trick that if A is equal to 1, right, I can just jump. Once I find my magic numbers, I can jump down. If you don't remember that, remember factoring 6.2. Alright, however, they didn't ask about U, they asked about x. They asked us to solve for x. So now I gotta go back and say, okay, since U equaled x squared, then that means 4 could equal x squared, right? Or 9 could equal x squared. And I gotta solve those real fast. Take the square root of both sides. End up getting plus or minus 2 is equal to x, or plus or minus 3 is equal to x. And those are my actual answers. So in order to make your life easier, you're going to substitute in, and then you're going to substitute out in order to actually answer the question. And that's U substitution. Alrighty. Let's try another one. So I got this thing here. It doesn't even look quadratic to begin with. 4x to the 6th plus 1 equals 5x to the 3rd. I'm going to change it so that it does look quadratic. We'll move this guy over. 4x6 minus 5x cubed plus 1 equals 0. Now in this case, the problem isn't so much that I have an x squared and an extra x squared, it's I have an extra x cubed, right? The second term here kind of always tells me what my u is going to be. So I'm going to let u equal x cubed. That way that'll just be a u, and hopefully this first term will be something squared so that I can actually use quadratic formula, or quadratic solving. So when I do that, I remember x to the 6th is going to be x to the 3rd squared. And we end up getting 4u squared minus 5u plus 1 is equal to 0. Again, I could solve this by factoring, but I think I'm going to complete the square so that we can practice with that as well. So I have 4u squared plus 5u plus 1 equals, no, I'm not going to do complete square. I'm going to do quadratic formula. So x is equal to minus b, can't write today, minus b plus or minus the square root of b squared minus 4 times a times c, 441, right? All over 2a. When I do that, now I can simplify. So I have 5 plus or minus, see, 5 squared would be 25, minus 4 times 4 is 16, over 8. Down here we got 5 plus or minus, let's see, 16, or 25 minus 16 is 9, square root of 9 is 3, over 8. And now I've got two answers. So 5 plus 3 over 8, and 5 minus 3 over 8. That would be 8 over 8, or 1. This would be 2 over 8, or 1/4. And those are my two solutions. So x is equal to 1, or 1/4. Alright, I'm sorry. Pardon me, that's horribly wrong. U is equal to 1 or 1/4. U is equal to 1 or 1/4. My very last step is to substitute in and solve that. So U is equal to 1 cubed, or sorry, x cubed. U is equal to x cubed. So x cubed is equal to 1, or x cubed is equal to 1/4. Take the cube root of both sides, and I'm going to do them at the same time. You get x is equal to the cube root of 1, or 1, right? Or, and this one doesn't really simplify, sorry, the cube root. X is equal to the cubed root of 1/4. And those are my actual answers. Alrighty. So those are my actual answers. I can't forget to substitute back in. So if I wanted to make sure I'd remind myself, maybe I could write this as u. That would be great. I can remind myself that u equals that. Later on I can go back and solve for x. Alright, let's try this one now. So I've got x to the 4th equals 6x squared minus 3. Again, doesn't look very quadratic like the last one did, so we're going to fix it the same way. Move things over. Got x to the 4th equals minus 6x squared minus 3, plus 3 equals 0. And now it seems pretty obvious what we should make our u sub. It should be that thing that's sitting next to b. So usually that's a general rule when it comes to u substitution. You want to change it to whatever's sitting next to your b term. If so, I'm going to let u equal x squared. When I do that, x to the 4th becomes u squared minus 6u plus 3 equals 0. This one I am going to factor, just for time's sake. Two things that add to 3, or multiply 3 and add to negative 6. Never mind, I'm not going to factor because nothing does that. So I'm going to use quadratic formula. Let's use quadratic formula. So x is equal to, u is equal to minus b plus or minus square root of b squared minus 4. A is 1, c is 3. All over 2a. That simplifies down to 6 plus or minus 36 minus 12 over 2 is equal to 6 plus or minus 36 minus 12 is going to be 24. Square root of 24 over 2. 24 is not a perfect square, but I can simplify it. 24 breaks into 4 and 6. That's 2, 2, 2, and 3. Pair of 2s. So we will drag back up here. So I have 6 plus or minus 2 root 6 over 2. Cancel, cancel, cancel. I end up with 3 plus or minus root 6 over 1. So I don't really need to write the over 1. So that's what u equals, right? That is what u equals. And in other words, that is what x squared equals, right? So x squared is equal to 3 plus or minus root 6. Take the square root of both sides. I get x is equal to plus or minus the square root of 3 plus or minus the square root of 6. Not the biggest answer in the book, but we can see that we have 4 answers here, right? We have a quartic equation to the 4th, and I have plus or minus the square root of this thing, so I've got 2 versions of it. And then inside I also have 2 versions, and so that's actually our final 4 answers. Sweet. Let's do it one more time. Actually, we're going to skip this one. No, we're not. We're going to do it. So let's do this one now. Same idea. I'm going to make u what my... Sorry, I'm trying to pick a color. I just found out I have all these other colors. I'm going to pick this color because that's cool. I'm going to make u whatever is sitting in my x term, or my b term here. So let u equal x squared. So I've got u squared plus 25u equal, plus 144 equals 0. And now I can use it in my quadratic solving methods. Just going to clean that up a little bit. Again, I think I'll use quadratic formula just because everybody seems to like it. So u equals minus b plus or minus the square root of b squared minus 4ac all over 2a. That ends up being minus 25 plus or minus the square root. 625 is 25 squared minus 4 times 144, and it's positive, so minus 144, or minus 4 times 144 would be 49 over 2. That is luckily a perfect square, so we get 25 plus or minus 7 over 2. So u is either negative 25 plus 7 over 2, which would be negative 25, negative 18 divided by 2, which is negative 9. Or it's negative 25 minus 7 over 2. Negative 25 minus 7 would be negative 32 divided by 2, which would be negative 16. So it looks like you can factor that one factor that one as well. But we get 2 answers for u, negative 9 and negative 16. So then in other words, x squared is negative 9, or x squared is negative 16. Square root, square root, square root, square root. We get x is equal to the square root of negative 9. It's going to be plus or minus, right? And then that would be 3 times I. We see that from the complex section. We get x is equal to plus or minus 4i in the second one. And those would be our 2 final answers. Alright, let's keep going. Let's do another one. Again, I'm going to let u equal x squared. Okay. Let u equal x squared. So I get u squared minus 37u plus 36 equals 0. Right? Instead of the x to the 4th equation. And then, let's see, 2 things that multiply to 36 and add to negative 37. That's going to be 37 and 36 and 30. Negative 36 and 1. So this is going to factor 2, negative 36 and negative 1. This equals 0. So u is equal to 36 or u is equal to 1. In other words, x squared is equal to 36 or x squared is equal to 1 after I substitute back, right? And I end up with x is equal to plus or minus 6, x is equal to plus or minus 1. That one worked out really well. That was a nice, easy substitution problem. We're going to skip this last one. Okay, so that is how you'd use U-sub. You basically find out what's sitting in your B term that needs to be replaced with U, so hopefully that ends up setting up a quadratic, right? If you've done it right. Let's see if we can do the same idea for something that looks like this. Not entirely quadratic, of quadratic form, right? We can see that if we maybe look at this thing here, we can set that equal to U, and then it will be of quadratic form. So let's go ahead and do that. So let's make U equal to 4x, whoops, equal to 4x minus 3. In other words, I'm going to take the pink stuff and I'm going to replace it with U. Complicated looking stuff, and replace it with U. Sweet. Now I have quadratic, much easier. Quadratic's much easier. So two things that multiply to 2 times 5 is 10, and add to 7, that would be 2 and 5. So 2u squared plus 2u plus 5u plus 5. Because a is not equal to 1, I cannot use that little trick, right? I have to actually do this problem. Actually do the grouping. Group and group. I get 2u, u plus 1, 5 plus 5, u plus 1 is equal to 0. Over here I get 2u plus 1, 2u plus 5, pardon me, and u plus 1 is equal to 0. So either u is equal to, let's see, subtract 5 divided by 2, negative 5 halves, or u is equal to negative 1. Now we substitute back in. So now it's not quite x squared we're substituting in for. It's going to be 4x minus 3 is equal to negative 5 halves, or 4x minus 3 is equal to negative 1. And then we can solve both of these. Well, let's go up here. 4x minus 3 is equal to negative 5 halves. Add 3, you get 4x is equal to 3 plus 3. That would be 6 halves, so that would end up being 1 half. And so x is equal to, divided by 4, you get 1/8. X is equal to 1/8. Or, if 4x minus 3 is equal to negative 1, add 3 to both sides. Yep. 4x is equal to 2, and x is equal to 1 half. So you get 1/8 or 1 half as the answer to this problem. But the same idea applies. Change whatever's sitting in your b term to u, and then hopefully it ends up being quadratic in the beginning as well. Let's do another one like that. So I'm going to again make u equal to k minus 4, because that's what's sitting in my b term. And when I do that, I end up getting u squared plus u minus 20 is equal to 0. Two things that will multiply to 20 and add to 1, negative 20, that would be 5 and negative 4. So this would be u minus 5 and u minus 4. In other words, u is equal to 5 or 4. Because of that, k minus 4 is equal to 5, or k minus 4 is equal to 4. Solve both of those. K is equal to 9, or k is equal to 8. Easy peasy, lemon squeezy. Alrighty, one last kind of dealio that we're going to be talking about is replacing a rational exponent. So remember, we've talked about rational exponents a lot in the last chapter. We know we can rewrite them. We've rewritten them quite a few ways as, quite a few ways to solve. So when things don't have a 1 in the denominator, we rewrote it so that it did, or 1 in the numerator, pardon me. We're going to play that same idea. But again, I'm just going to let u be what's sitting in the b zone. So I've got let u equals x to the 1/3 right? And I can replace it. 2u, well, if u is 1/3, right, u is x to the 1/3, 2 of them would make it u squared, minus 11u plus 12 equals 0. Alright, two things that multiply to 2 times 12, so the two things that multiply to 20 and add to negative 11, it's not 20, 24, that would be negative 8 and negative 3. So 2u squared minus 8u minus 3u plus 12 equals 0. And then we factor by grouping. Here I can pull out a common 2u. I'm left with u minus 4. Here I can pull out a negative 3. I can pull out a u minus 4 is left over. So I get that u minus 4 times 2u minus 3 is equal to 0. Or in other words, u is equal to 4, or u is equal to 3/2. Last part, substitute that x back in. Right, substitute the x back in. So x to the 1/3 is equal to 4, or x to the 1/3 is equal to 3/2. If I wanted to cancel this on both sides and I want to get a whole x, then I just multiply this by 3. Sorry, I cube this. I multiply it by 3. I cube this so that those cancel. So I cube this one as well. I get x is equal to 64. Same thing over here. I'll cube this one. Cancel, cancel. I'm just left with x. Cube this one, and if I cube a fraction, I cube the top. That would be 27. And I cube the bottom over 8. And those would be my two final answers. Alrighty. Let's try one more of those so we can kind of close out this concept. So this one's a t, not to be confused, but I'm going to let u equal that thing next to t, right? So let u equal t to the 2/3. And then I can see that if a t to the 2/3 is here, I'm going to get u squared over there because it's two of them. So I end up with 9u squared minus 25u plus 16 equals 0. Now I've noticed I've got squares on both ends, so let me double check if this is a special case. Let's see, squared on the person, that's 3 times 4 times 2, 12 times 2 is 24. Darn it, it's not a special case. That's okay. Maybe I'll just use quadratic formula. So u is equal to minus b plus or minus square root of 25 squared minus 4 times 9 times 16 all over 2 times 8. Is this negative? Yeah, okay, cool. So I end up getting 25 plus or minus, let's see, 25 squared, 625 minus 4 times 9 times 16. That ends up being 49 under radical. And divide the whole thing by 18. Hey, that's a nice pretty square root. So that's 25 plus 7 over 18. This is sounding familiar. Oh, sorry. Positive. So that would be, let's see, 25 plus 7. It's 32 divided by 18 is not going to be a whole number, but I can reduce them both by 2. I get 16 over 9. Okay, so I get 16 over 9. Yep. And the other one would be, I'll write it up here, 25 minus 7 over 18, which would be 18 over 18, or 1. Very last step, I got to substitute that t back in, so t to the 2/3 is equal to 1. If I want to cancel that, I'll take the 3/2 power. That way it goes cancel, 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 cancel. Well, 1 to the 3/2 is going to be the square root of 1, right? So if I convert that, that's 2 root 1 cubed. So 1 cubed is 1, square root that's just going to be another 1. Okay? And then I also have t to the 3/2. I'm sorry. I have t to the 2/3 is equal to 16 over 9. I got 3/2 that. 3/2 that. Those cancel to just t. That leaves me with the square root of 16 over 9 cubed. And I end up getting, let's see, the square root of that would be 4/3 cubed. So 64 over 27. And I have my final answers. 1 and 64 over 27. Okay, so U substitution, very important. I hope that answered your questions. Otherwise, shoot me an email. And if not, or if everything's good, then I will see you in the